Another day, another slave. Today we are here to discover the other story, which is the second law of motion. Daydreamers, let us tackle the second law of motion by Isaac Newton.
Wow.
The second law of motion states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. In simpler terms, a greater force will cause a greater acceleration, while a larger mass will result in a smaller acceleration for the same force.
Yeah. But wait, is the second law of motion even important?
Yes, of course. The second law of motion is the key to understand movement. It is used for many areas, from design vehicles to studying plants and atoms. Help us to predict how things move and build better systems.
And now, here are 3 examples of the second law of motion.
Rocket launching into space. When a rocket launches into space, the rocket's engines generate a force that propels the rocket forward. According to Newton's second law, the acceleration of the rocket depends on the force applied to it. If the rocket's engines generate a small force, the rocket will only accelerate slowly. But if they generate a greater force, the rocket will accelerate fast. This is why rockets are able to travel at high speeds and reach outer space because their engines can generate a very large force. Third, a person riding a bicycle. When a person pedals a bicycle, the force they apply to the pedals determines the speed of the bicycle. The acceleration of the bicycle depends on the force applied to it. If the person pedals slow, the bicycle will move slow. But if they pedal harder, the bicycle will move faster. This is the reason why professional cyclists are able to travel at high speeds because they can apply a greater force to the pedal.
This formula that you can see on your screen is probably the most important formula that you will use in grade 11 and parts of grade 12. F net equals to ma. It is Newton's second law, expressed as a mathematical formula. So, in the previous lesson, we looked at the definition of Newton's second law, and here it is again. And so what I'm going to do is I'm quickly going to take this expression and I'm going to get A by itself. So what you would end up with is A is equal to F net over mass. So it says here that the acceleration of an object is inversely proportional to the mass. That is why the mass is at the bottom, and directly proportional to the net force. And so that's why the net force is at the top. So this formula is all of that, but in a mathematical expression. So you can actually use it in a calculation. So look how easy this is. Let's say you've got this object over here. Someone's pulling it to the right with 20 newtons and someone's pulling to the left with 5 newtons. Is the object going to move right or left? Well, obviously it's going to move to the right. What would the overall effect be? Well, that's going to be 15 newtons to the right. I hope that makes sense. If someone's pulling with 20 newtons that way and 5 newtons that way, then the overall effect is 15 newtons to the right. So you could almost replace this picture with this, like that. There's no difference between the two. Both objects would move at the exact same rate or acceleration, because 20 minus 5 is the same as just having one force of 15 newtons. Now that 15 newtons, that is what we call F net. Net is it means result. So the total result after everything has been done. It's almost like the profit. Let's say your business earns 20 million rand in a year, and then you owe expenses of 5 million rand. That means your total profit is 15 million rand. That's what F net is. M stands for mass, so it's the mass of the object, and then A is the acceleration. So if F net is 15 and the mass is 10, then we can work out the acceleration as 15 divided by 10, and that's going to give you 1.5. Now remember, the acceleration is how much by half. In 1 second, how much does the velocity change? Now velocity is measured in meters per second. So if you want to know how the velocity is changing in meters per second every single second, then acceleration is meters per second to the negative 2 because we're saying meters per second per second.
That's all for today, dreamers. Goodbye.